So they are telling me that this flower pot falls, okay? That's keyword, okay? From a windowsill 25 meters above the sidewalk, okay? So I don't have a sketch. I don't have any sketch, so I recommend to do it. So, so I imagine that I have like a kind of a building, okay? I know it. Okay, so this windowsill is located at 25 meters above the sidewalk, okay? Let's talk about the sidewalk. The sidewalk is right here, okay? So it is located 25 meters above. That is important to know the location. Now, what else? What else? It says in part A, it says how fast is the flower pot moving when it strikes the ground. So they're asking me how fast when it strikes the ground. Okay. So they're asking me about how fast tells me about the speed of an object. So it is asking me about a velocity. Velocity in what point? When it strikes the ground. So you have to analyze. Striking the ground, is that going to be a final condition of the object, or is it going to be an initial condition of the object? So you have to think, imagine what happens, okay? So when you do that, you're going to have this as a result, okay? So initially, your object was there in the windowsill, okay? After it falls down, it looks more like that. So when it strikes the ground, it represents actually what we know as the final condition of the object. One reason. The second reason is because in the beginning, it says that the flower pot falls down. Falling down represents an initial velocity of 0. Okay. Now in part B it says how much time does a passerby on the sidewalk below have to move out of the way before the flower pot hits the ground. So they're asking me about the time. There's nothing more to say about it. Okay. So what do we do in the first place? We work with the delta y. Okay, delta y. Just think. You're not seeing anything. Wait.
Always we have to do delta y in every exercise of free fall.
It's good that you get the delta y, even if it takes 1 minute longer to do it. It's good that you do it. Wait a second. I'm going to turn on and off my. Yeah. Let's see. So my delta y, how much is it? Okay, so delta y refers to the difference in height. In height because we're talking about vertical position, okay? You can also call it a difference in position, it's okay. Now, delta y is measured as y final minus y initial, okay? So if my initial position is right here in the top and my final position is right here in the bottom, I have to write it in the delta y formula. So delta y is going to be equal to the final height that is right here, that is on the ground. Remember, if I put this axis here, okay, if I put an axis over there, I know that in this side I have my 25 meters, and in this point right here I have 0 meters. Okay, so that's always good that if you can draw a reference. Okay, and a good reference is always a coordinate plane. You can do it with a pencil. Don't try to skip it. I know that it's meh. I know these kind of exercises are very like that. But trust me, it is very good that you take my advice in consideration, okay? So let's analyze this. For delta y, my final position, as you can see, it's in the bottom, which is 0 meters, and my initial position is above, and it's 25 meters. This minus is from the formula. So my delta y in the end is equal to negative 25 meters. Now, there's another way to do it without making the formula process. That is just analyze where was the object in the beginning and where was in the end. The object initially was over, above, or was below. So you have to analyze. So sometimes what I do, I skip this step because what I analyze is this. The object ends up below the first position. So delta y is going to be negative. In my brain, that's how I do it. Okay, if I don't want to do any calculation like delta y formula, that's how I do it. Okay, I just analyze where is the object in the end. Ah, the flower pot is on the sidewalk. The sidewalk is below the windowsill. So the change in position is going to be negative because it ended in a lower position than it was before. So honestly, in my daily life, I don't do this procedure. What I do is I just analyze this. You can do either way. Now, if you are just going to put the negative symbol, explain me why the negative symbol is there. Don't write the negative just because when I am checking, I think, okay, where does it come from? I know the reason, but do you know? So you always have to explain why you take some decisions, okay, in the procedures, because I check procedures. Now you can do either way over there. In the step number 2, what do we do? Let's
Find the
focus
f.
on the question. Which it says that I need to find the velocity, okay? And the formula that we have for final velocity is equal to the square root of initial velocity
Square.
to the second power plus 2 times gravity times delta y, okay? This formula, guys, I know that sometimes you are that you don't know what to do because you say, I don't know what formula I have to use. That's one of the most common questions in physics. Miss, how do you know what formula to use? Here is very simple. The problem doesn't give me time. And this is the most useful formula because it doesn't have time. Okay? So, and again, you know the initial velocity, you know the gravity, it's implicit. Okay? Because even though the planet is not specified over there, I doubt that in Mars you can find a building like that. Okay? So, let's assume it's on Earth. Okay? If it's not specified in other way, assume it's Earth. So use gravity, Earth's gravity. And then delta y that we just got. So we have everything we need. So we say, remember that here the initial velocity is 0, so just ignore it. So you're going to have 2 gravity delta y. And in the end, we have square root of 2 times negative 9.81 meter over second squared times delta y that we said is negative 25 meters. Meters and meters are gonna give you square. Guys, I know that you are very lazy, just like me, in the way that you want to do the procedure in 2 steps. Look, I am your teacher, and I do all the process. That's the least I expect from you. Even if you have a really high IQ, I want to see all the procedure, all the steps. Okay? So, here, negative and negative is going to give you a positive 1. And multiplying 2 times 9.81 times 25 gives you how much?
490.5.
490.5. Meters times meter gives you meters to the second power. Meters and meters give you meters to the second power. And all this is divided by seconds squared.
Per second.
So how much is this?
22.14 meters per
22.1 ms.
22.1.
1.
And here is meters over second.
Why did you take 1 point from after the decimal point?
Wait, I got the full. Wait. So I got full. I almost cried. So you were saying why I did what?
Why did you take 1 digit after the decimal point?
Well, I don't know. I just trust what you said. Okay, so I did it now, and I got 22.15.
Yeah, 22.15.
Okay, so you can write the 2 digits for me. It's okay. I like it even more. Okay. Once you have the final velocity, we can go directly to the to answer the part B.
Means that 22 stay positive or it will be negative.
It's going to be negative. I wanted to talk about it in the other part, okay? But yes, it's going to be negative because remember that the
Goes
final
down, right?
velocity the object is going down, okay? And because the object goes downward, the sign is gonna be negative. That's why. Now, the step 3, that is about the time, okay? We have an equation that says that delta t equals delta v. Delta v divided by gravity. Now, what's delta v? By definition is final minus initial position. In this case, position, in this case velocities, and gravity that you know Earth's gravity. Okay, so you say, and take a look, I'm writing the definition of the formula, and then I plug in the givens. The final velocity gave me -22.15 meters per second, minus, this minus is from the formula, okay, and initial velocity, that is 0. You can totally ignore it. If you ignore it, you don't need to put the negative symbol over there. Okay. And what do we have below? We have gravity, which is 9.81 meters over second squared. Negative. So we cancel here meters with meters and seconds with one of the seconds over here. And the final answer that you will get is going to be in just seconds. What is delta t?
2.25.
2.25 seconds.
2.25 seconds. Remember, when you get a time, a negative time means that you did something wrong about signs. Okay? So if, for example, we forget to put the negative symbol here, therefore we put it there positive. Okay? So it's going to give you a negative time, but negative time is not possible because you cannot go back in time. Okay, so when this happens to you, just analyze the symbols. Say, okay, what did I do wrong? And start checking and start analyzing. You say, final velocity, I have it positive. And try to remember, how is the object moving? The object is going down, so you have to put a negative here, which is going to make it positive. But also don't forget to put it over there. That's a way how you fix it. Because I know that when you are in the middle of a quiz, for example, the least thing that you want to do is to notice that you have a negative time. Trust me, my students have told me years before, they have told me, Miss, in the exam I got a negative time. I didn't know what to do. I studied a lot, but I got a negative time. And because I always tell them, I always tell two things in the beginning of the school year. One is that in my true or false questions, they are always false. They never believe me, but I tell them, okay? And also in that the time should never be negative. Always positive on the time. If it had negative means, I should do something wrong, okay? So they get frustrated because of that.
Miss,
Just
the answer that you just made is not 2.26 because there's a 7 after 5, so we should round it.
As I told you, I just trust what people say and I put it. I actually didn't do it.
I just analyzed after I give the answer.
I'm going to do it.
But yeah, it's 2.26 seconds.
Okay.
Yeah, Miss. So we
Yes,
put that answer
right.
in the homework instead on the one you put in the classroom.
Yeah, I mean,
You
really
see the
definitely
answers.
in the notebook, okay? Put the homework there in the notebook with the rest of the exercise. Just show all your work, okay? That's all I'm asking. Remember, I do all procedure. That's all I expect from my students, that they do all the procedure. even if it takes longer. I would explain you the reason, but I prefer to do the exercise number 4. It says calculate the displacement of the volleyball in sample problem F. Okay, so to know what we're talking about, we need to take a look to the sample problem F. So then it says when the volleyball's final velocity is 1.1 meter over second upward. Okay, so here, what do we need to get? We need to get information from sample problem F and include this data over here. Final velocity 1.1 meter over second, and the problem tells me that it's upward, so it's going to be positive. Remember, here it is very important to know about the signs. So, what do we know from the problem F? We know that it has an initial velocity of 6 meters over second, and the volleyball starts from 2 meters above the floor. Okay? That's all we have. So let's write the information that we have. It says initial velocity, which is 6 meters over second, and initial position is 2 meters above the floor. So this represents a positive sign because it says above. Okay. Now what else? It says, okay, they are giving me also a final velocity of 1.1 meters over second. And it says upward. So, because they're telling me that it's upward, you know that it's going to be positive. So just put a sign. Okay? Now, what do we need to know? Okay, first, that's everything we have. We have the initial position, okay? We have a delta V. And let's take a look to the formulas that we can use. So, from the formula before, that we used before, I know that I have the formula for delta Y, for final velocity, for delta T. Okay? So, as you can see, I have delta T. Okay? Delta T, I don't have it, but I can get it easily. Because I have the two velocities, I have the final and the initial velocity, I have it, and I have the gravity. So let's begin with working with that time. Okay, so in the first step, we can get the time. Delta T equals delta V divided by gravity. I cannot give you, for this kind of exercises, I cannot give you like a path that you could follow because it depends on the givens that you have, the formulas that you have to use. Okay, so I saw that delta T was good. Okay, so I'm gonna use it. So what do I have for delta V? I have a final minus initial velocity divided by gravity. Okay, now my final velocity, sorry, is equal to 1.1 positive. Okay, and the initial velocity is 6.0 meters over second. Sorry, I didn't put this. It says straight upward. That's also important that you write it. So, because it says upward, we're going to consider this to be positive. Okay? And because it says, this word is also important, because it says straight. Straight means that it's moving in a single direction. Okay? So that means that it's not thrown at an angle. Okay? It's not like this Jason throw the ball at an angle. No, it means the opposite. Okay? It means that it's completely straight. So you can consider a straight path to be at an angle of 90 degrees. Okay? So that's what it means. Take a look. Now, here is 6 meters over second. 6 meters over second. Positive, both of them. But here, take a look. Positive is not going to cause any change. And here, negative and positive is going to give you the same negative that you had before. Okay? So you just leave it there. And the gravity, which is negative 9.81 meters over second squared. Now, take a look, guys, because I noticed that you commit this kind of mistakes. First, we are going to subtract. How much is this? 1.1 minus 6.
Negative 4.9.
Negative 4.9.
Negative 4.9 meters over second. Sorry. Divided by negative 9.81, how much is this?
0.5
seconds.
The units cancel, 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 and cancel. And this is, as we already said, seconds. Oh my god, my nose. Okay. Okay, just to finish to explain the example number 4, after you have found the time, we need to look for an equation where calculating the change in position is gonna be possible, okay, because it tells you, the problem tells you that calculate the displacement of the volleyball. So we need to calculate the change in position, okay? So in the formula that we always use to calculate the final velocity, we can make an arrangement with an isolation process in order to get delta y. Why is this formula so useful? You had the final velocities given in the problem. You have the initial velocity, which is also given in the problem. 2 is a constant. Gravity is a constant almost. And delta y is your unknown, which means that you can make an isolation process to get it. So the first thing I do is this initial velocity, I send it to the other side by making a different operation. In this case it was adding, now will be subtracting, just like I have over here. And then this is going to be equal to the remaining of the formula. Then, because I need to isolate delta y, 2g is multiplying delta y, which means that if I want to isolate it, I need to send it to the other side of the equation, but making the opposite operation. In this case, it is multiplying. When it goes to the other side, it goes to divide. And in this way, we have the formula already isolated for delta y. Now, that's the isolation process, but you can keep the formula handy in case that you need it later. Okay? Now, as I told you, try to work, or it is mandatory to work step by step. That's why here I did the step-by-step procedure. And it says delta y equals final velocity squared minus initial velocity squared, all that divided by twice the gravity. So what I do first, I solve the powers. 1.1 squared is 1.21 meters squared over second squared, because you raise the number to the second power but also the units. Now this minus is from the formula, and then 6 meters per second raised to the second power gives you 36. But also remember to raise the units to the second power too. Okay? Now that you have solved the powers, also multiply what you have in the denominator. Okay? 2 times negative 9.81 gives you negative 19.62. Now the other part is to subtract. What are you going to subtract? Well, the subtraction process. Here, 1.21 minus 36 gives me negative 34.79. Please don't forget the negative sign. Now, all this is going to be divided by the denominator from the step before. Okay? And after you get all this, it comes the last step, that is to divide. When you divide, the negatives are gonna be cancelled, or negative divided by negative turns into a positive sign. So 34.79 divided by 19.62 gives you 1.77 meters, or approximately equal to 1.8 meters. Okay? And meters, because here you cancel the second square with the second square, and one of the meters with the single meter over here. Once you have done it, just analyze the answer. Okay? And now here I explain you what the positive sign represents. This positive sign from your answer represents a positive change in the vertical position. So a positive change means that the object ends up in a higher position than it was initially. And it makes sense, because remember, Jason is hitting the volleyball upward. Okay, so yes, it makes sense. Always try to analyze if your exercises are, your answers make sense or not. So this is it for the exercise number 4. Get ready. Okay, study hard for the quiz.